So this isn't just a spreadsheet. We're talking about demographics, reasons for stops, actions taken, and more, with the key points, the points like race, ethnicity, violation types, and officer's decision. This data set offers a hard look at how police policies and practices might favor or disadvantage specific groups. Our goal to expose any patterns and disparities in police stops using raw data, real insights. We're investigating, are certain groups biased when they get stopped? We're going to use, so we did basically use police stops in San Diego. This is by Pavan Tanbir and Victor. This is our introduction. It comes straight from the San Diego Police Department. So we're going to set the stage first, basically insert the data. That will be load the data into it, into the Google Colab. Then we're going to assess the data, then clean the data, merge the data sets, inspect the merged data set using .info and .isno and .sum. And then in the final step, we're going to save the clean data into our masterpiece. So let's get this started. And the reason why we chose this data, because, even as teenagers, nothing racial, we get pulled by the police. It's why you get pulled, what happens, and the aftermath. Basically, we combine 6 data sets into 3. So first we load. Step 1, load the data set. We load and we get unfiltered data. And now we're going to use .info and .describe to actually assess the data. This is what we get after we assess the data. And then we're going to clean the data. After we assess the data, we're going to clean the data. We're going to find the missing values, statistics for each. Missing values is no, sum, actual columns, data frames. Replace the columns with actual column names. Unknown columns convert into columns. And this is the result. We find the statistics. We find the columns that are empty. Now identify and drop the rows. Now to clean the data sets, the unnecessary, to filter this data, we found the result stop ID. These are columns that are unused. Now we're going to fill the missing categorical data. And as you can see, all this works. It replaces it. Now we're going to convert the columns to numeric errors. Standardize the column names. Standard str function. We found the empties or the underscores. Now we're going to convert the data. We basically converted it. Now we're going to remove the duplicates because they take up space. Now we're going to merge the data sets. Once we merge the data sets, we're going to drop the duplicates. Pandas frame, drop duplicates. Feature engineering. Merge everything together. After we drop the columns, create new columns. And this is the result. This is our masterpiece.
Hi, so in this next section, we're going to be discussing our exploratory data analysis. We'll then discuss our model selection and then our model analysis. So we begin our exploratory data analysis by visualizing and diving into the breakdown of police stops by race and compare this to the population percentage by race. So at this point, we've broken down our data to the racial categories that have the highest amount of police stops. The racial categories are as follows and listed in alphabetical order: Asian, Black, Hispanic, and White. We first plot the comparison, and it becomes immediately clear that of the 4 racial categories, Blacks and Hispanic percentage of stops exceeds the population percentage. This leads us to continue down this path of exploration. In this side-by-side comparison, it's easier to see the differences between the 4 racial groups. The orange bar shows the percentage of stops by race, while the blue bar shows their representation in the population of the city of San Diego. So based on this initial exploratory data analysis, it appears that we will eventually focus on this. We now have to move on to finding the best prediction model for our data. So we begin by running our data set through a logistic regression model, where we compare stops by race to the result of the stop. So based on this model, we see a high success rate in being able to predict the result of the police stop in each racial category. However, this doesn't tell us much about the probability of each racial group getting stopped. When we rerun the logistic regression model to predict the probability of racial groups being stopped by police, it does not yield great results. In fact, only a 50% success rate. So this leads us to try other models. So next we ran our data through an odds ratio model. we then ran through a general linear regression model and did not yield great results. In fact, this chart here shows the odds ratio, and it shows blacks and Hispanics are much higher than Asian and white by a huge margin, almost a nonsensical amount. The model that we eventually selected is the chi-square test of independence, and that's where we found success. So if you look at our analysis here, we show the number of stops, and these are the number of actual stops recorded, and then the chi-squared model predicts an expected number of stops based on racial group. And so let's visualize this. And so the results from the chi-square test of independence provide strong statistical significance of racial disparities in police stops in San Diego. And if you look at this chart here, the blue bar shows the observed stops, and the orange bar shows what's expected. So if you look at blacks and Hispanics, blacks should be expected much less to be stopped. Hispanics should be expected to be stopped less as well.
Hey, yeah, thanks, Victor and Tatbir. So yeah, we selected the chi-square test of independence as our primary statistical method because it effectively evaluates the relationship between two categorical variables. In our case, that would be race and police stops. As you can see here, as Victor mentioned, we can see significant differences between Hispanics and blacks. Next, we look at the p-value and the chi-square statistics of 573.61 and the p-value that is significantly lower than the common alpha level of 0.05. This finding tells us that certain racial groups are stopped by police at rates that are significantly different than their population representation, suggesting systematic biases within policing practices. By looking at this graph here, we see that blacks and Hispanic individuals are disproportionately affected by police stops and police practices. Some of the limitations of the studies include data completeness and data accuracy, mostly stemming from incomplete data and errors during reporting. Contextual factors, such as external factors influencing the police's behavior, which may not be captured, such as vacations or high crime areas or just time of the day. We also need to keep in mind that causation versus correlation. While we do identify associations with the chi-square test and the p-values, causation cannot be established here. And just the public perception, given the high public cases in the past few years. Next step moving forward would be to do more future research, maybe some longitudinal research and analysis that spans over time to assess the various trends in this area or even the population of the United States. We could also look at doing some policy recommendations based on the findings of our research. We could collaborate with the community organizations to see how they feel and are affected by this. As you can see from our data that there is some kind of bias here. So that could also be used for public awareness campaigns, and we could use that information to get funding for trainings, not just for police, but also for the community members. That is the end of our presentation. Thank you so much for your time, and hopefully this has been informative. Thank you.